I had a little interruption. I'm back, so let's see how this works out. Okay, I'm live. Welcome back. Welcome back. I know it's only been a few seconds, but I like to introduce myself every time I disconnect and reconnect. And that's exactly what I'm doing now. I'm gonna go ahead and close YouTube. Oh, shouldn't close the whole thing now. Yeah, he's still here though. Hmm, Let me make sure. Yeah. Oh, um, let me open up a browser window just to have him there. Have my Gemini guy still there. So we installed the appropriate application, which the next application we had to install was the QN 2.5, 7 bits. And based on what he told me, it was 8, and it was QN 3. So I'm not sure what happened there. This is 2.5. Let me see. Okay. So it gives us headroom. So he's comparing the 2.5 with the 3, Q13. 8. I believe this is bits. I don't know why. Hey, wait, let me ask my guy over here. This is his purpose. Even though he could do a lot more, right? That's fine. Everybody has a purpose, right? What does the B stand for? In the model name, the B stands for billion. Wow. Well, I was talking about bits. It refers to the numbers of parameters, often called weights, the model has. Therefore, 7B means that this specific model contains approximately 7 billion parameters. Wow, that's more than enough. Parameters are the internal variables the model uses to understand and generate text. The parameters count indicates the overall size of the model. Generally, models with a higher parameter count are more capable, but they also require more computer memory and processing power to run. That's fine. All right. So we could have had one more billion. Instead, we have 7 instead of 8. That's, yeah. So he gives us an explanation as to why it's okay, right? Which he says that it leaves more GPU headroom than 8 billion while OBS is running. So less processing power, right? By 1 billion. That's what I that's what he means, okay? So now we need to make check the list. All right, so let's do that. Let's go. So now it's not empty. So everything's correct. And it took 5 minutes ago. Let me give him this. Send me the result. Wait. So then perform the basic JSON generation test. So let's perform this, and then we give him final request, final response. I mean, my camera went out, people. You know what that means? I have to turn it back on. Man, why did it do that? All right. So my video. Oh, yeah. There seems to be yeah, my camera is acting up. Let me see if I can fix it. And this is because of what's going on with the installation and all that. I believe. So let me reset it. Hopefully it's not gonna cause any more interruptions and yeah, that's fine. Hmm. It's looking a little sluggish over there. Yeah. Yeah, let me take them off for now. I'll bring them back. I'll bring my extravagant mass camera back. A few after it's done here. Building a local AI video clipper. Oh, look at that. Description. Developing a tool that uses artificial intelligence to automatically clip videos based on user-defined parameters, all processed locally without requiring an internet connection. Look at that. Oh, that's cool. So let's give them let me see. Tell me the results. This will confirm the model can run locally before we connect it to the metadata generator. So system. Q1 2.57b will generate clip title descriptions now and can later provide local tool selections through Olama. Great. That's just great. Oh, wow. Okay, did I Control Alt on screen? Right. And this is all right. The model download and local generation both succeeded. The code fence show why the application must use Olama structure output API and validate the response instead of trusting prompt wording alone. I am confirming the current official request format before defining the metadata milestones. So, success. Olama are working locally. Olama and QN are working locally. Great. So that means without internet connection, I can get this done. Um, the title and the description, I believe, is what we're speaking about. The response contains markdown fence despite only JSON. That is expected from ordinary prompting and confirms why our application must use Olama's JSON schema mode. Olama officially supports passing a JSON schema in the format field, which constrains output structure more reliably. So milestone 8, title and SEO description. So paste this into Copilot agent. We are getting along, people. We are getting along. All right, let me see if my camera is working now. Even though, is he still typing? No, he's not. See, I know he's still like typing when the page is moving up and down. When the words and the letters and the paragraphs and everything in the content area is moving up and down. It's because he's still typing. So stop moving. That means that he stopped typing. All right. So let me look and see how we looking over here. Is it still freezing a little bit? No, looking very good. Okay. We're back to normal, people. I guess it's because the installation and the download was slowing us down. And I really don't like how I'm more to the right than I should be. Yeah, it still looks a little finicky. All right. Let me see. Yeah, it does. I do look a little. Yeah. I'm gonna have to look at that when I get the chance. All right, guys. So let's go ahead and paste this into Copilot. I'm gonna go ahead and do that right now. Okay. Well, Copilot has his work cut out because he's doing all the heavy lifting, and that's what I expected out of all my developers. He should be doing the development because VS Code, right? That's where the coding occurs. It's just that simple. So he's gonna, it says here, implementing milestone 8 end to end with metadata generation, conservative fallback, processor wiring, manifest writing, schema docs, and tests while preserving existing pipeline components. Let me take a look at my tokens real quick. Because on Saturdays, they go by quick. And I think it's because so many people are online that you just got to pay up because there's the line, there's a huge line, of prompts, right? All right, so implementing milestone 8 end to end with metadata generation, conservative fallback, processor wiring, manifest writings, schemas, docs, and tests while preserving existing pipeline components. I'll first inspect the reference type modules and run baseline validation so changes are scooped safely before editing. I am gathering repository conventions and locating all metadata related touch points so the implementation matches existing patterns and typing styles. So I'm gonna click allow. So I identify the key integration points. How does it look like? An existing placeholder. Next, I'll run the baseline validation you requested. I'm looking at my bit rates right now and the total data because it looks like I'm lagging. Next, I'll run the baseline validation you requested before any edits, then implement metadata context manifest changes with tests. So baseline node validation is clean. I am now running the Python regression command you specified to confirm no pre-existing worker regression before implementing milestone 8. With baseline passing, I am expecting environment bootstrap and config and existing metadata related tests so I can add the new provider cleanly and keep default local behaviors intact. So I've confirmed config is currently minimum and metadata is still a placeholder. Next, I am mapping runtime, wiring, and environment docs so I can add a llama config and manifest behaviors without breaking current startup flow. I found there's no app bootstrap yet, so I'm implementing inside existing modules on test directly. Now I'm reading cutter patterns for automatic file handling, type errors to mirror style for manifest writing. I have enough context to implement safely. Next, I am making a focus change of set across types, metadata modules, processor writing, wiring. Okay, I'm starting the code changes by expanding type metadata contracts and config surface so the new context builder and a llama generator can stay strongly typed and failure safe. I'm now implementing a dedicated metadata context builder module with transcript overlap, extractions, beginning, middle, and truncations, sampling, and conservative. Okay, so I think he's gonna print the final response. Next, I'm writing processor to pass full per clip context into the metadata generator, force clip index mapping, safeguard, and write an atomic manifest after successful clip cutting and metadata generation. That's a whole lot of information, brother. You understand all that, good for you, but I like to read because reading is fundamental. I've updated processor integration mocks to satisfy the new clip index metadata contract. I am now adding dedicated metadata context generator manifest test to cover all required validation and failure scenarios with mock HTTP hypertext transfer protocol. So I've completed the core implementation and test scaffold, and next I am updating environment documentation and README to reflect Olama's default structure output behavior sold by policy and manifest detail for milestone 8. So I finished the implementation and test additions. I am now running type check test build to catch any compiler behavioral issues, and then I'll iterate on failures until clean. So he's iterating through the failures. Basically, he's fixing them. Though I recall that at one point he would give me a final response. And I believe it's because ChatGPT instructed him to do so. Maybe in this case, ChatGPT did not instruct him in the prompt that I gave him, which is milestone 8 prompt, or maybe not. Okay, this is the part where he gives me the final result. He's still trying. I wonder why. It's nice that they're gonna do the what was it called again? OES? Yeah, SEOs. I wonder if they're gonna add also hashtags. That's very important. Let me allow. Hello? Hello? Okay. Oh, was it good? Copilot has been working on this problem for a while and can continue to iterate, or you can send a message to refine your prompt. So Vitesse passed, but the type check and build didn't, or it caught an exact optional typing issue in the text. Let me click continue as I usually do. Mm, okay, this is the part I was hoping to get sooner than later. I hope I'm pressing the keep button. I think I am. Let's keep. Now let's give my guy the final result or response. I used to read this whole response, but it's become so lengthy. I'm not reading it anymore. Okay, so let's see what he says over here at the bottom. So what this milestone adds, for every clip, the application will transform its transcript or available production evidence into a title and a 2 to 3 sentence description. The results will be saved alongside the clip manifest. The JSON, the model is entirely local and free because QN 2.57B occupies about 4.7 gigabytes. Metadata generation should occur after Whisper X's, so both models will not compete for your 8 GB VRAM. So system note, the generate clip metadata schema will later let the assistant request metadata safely while fixed application prompt schemas and validation prevents arbitrary model system prompt control. Oh, let's paste this last response. Let's press enter. Well, at least it doesn't say reconnect. Now it says working for X amount of time. 11 seconds, 12, 13, 14, 15. Anything other than reconnect. Context automatically compacting. Right? Okay. Still thinking. I was thinking for much longer than usual. It's going on for a minute now. It's reconnecting. It's funny how I just noticed that he's reconnecting. And something's telling me because it's the weekend. So I'll read the milestone 8 report. No, I've read the so then I'll read. Then I'll give you a short senior level review and exact next validation step. All right, I'm gonna click allow once. The file reader hit the same window process launch restrictions we've seen before. I'm requesting read access only to that attached report so I can review it exact. I want to give him full access. He already know what he's doing. You already know that he shouldn't tamper with the code unless if he prompts me to. I received permission, but Windows still blocked the local command runner from opening the attachment. This is a codex process launch issue, not a problem with your project or file permission. Please paste the milestone A report directly into the chat. As you did previously, I'll review it and confirm. Can we fix this instead? Like, I'm tired of having to do this. I want you to have full permission. Can we give you permission for future read now? Let me see. You can grant broader folder access, but that would not fix a specific error. You already granted permission to read the attachment. The failure occurs because PowerShell started Create process as user failed 5. Access is denied. That means Codex window command runner was blocked from launching. Not the file itself was inaccessible. Giving me access to the entire would be unnecessarily broad and still might not solve it. For future, keep the project folder open. Attach as the Codex workspace when you want direct file access. Grant a specific folder when Codex displays a permission request. Avoid granting unrestricted computer-wide access. If this launch error continues, restart Codex and reopen the project folder. If a Codex restart is more likely to fix it than changing file permission. For the current attachment, paste its text directly into chat. Your project files are safe. This is a Codex environment issue, not a smart video clipper error. Alright. He really doesn't want to do that. Like, I don't understand why he doesn't want to go through that change. And I remember when we first started this whole project, Codex wanted to be the one like writing the code and everything. And he wanted to start the project in the file explorer here somewhere. Again, guys, this is the first time I use Codex, and that's what I recall. And I decided to give all that power permission to VS Code, and that's where I think we are having that little issue. He doesn't really want to go over that again, I guess. So, and the computer, I can't see it because my mic is in the way. So when I look, I have to like peer. For some reason, now it's saying that it dropped frames by 1.5%, and I don't like that. So let me reset it. Hopefully that helps. Usually it does. So I'm gonna reset my OBS stats. Maybe that'll make things better. Okay, so let's go ahead and copy this again. Well, the response. Copy final response, and hopefully it doesn't turn into the text. Yeah, it did. Showing text field. Let me see. There you go. Okay, so this should be good enough. This should work. Milestone 8 is architecturally solid and preserves the project correctly. The automated test passed, but final approval requires the real Olama integration test. The scaffold was skipped during the normal test run. So run this from the project root. Okay. So I guess this means the project root, right? Not from the chat. Something like that. Okay, so now we got this error. So let me read what this means. So what this verifies? No sends real clip context to your locally running QN model. Receives schema constraint JSON, validates it, and produces an acceptable title and 2 to 3 sentence description. One minor feature hardening item. The implementation bound message.content after downloading the HTTP response. Later, we should also bound the total response while streaming it, protecting memory if a local server returns an unexpectedly enormous response. This does not block the present local integration test. After, clear the temporary settings. However, what preview? What's that about? Wait, what is this? Let me keep reading. Short recap. Milestone A gives every finished clip locally generated metadata, uses transcript evidence when available, avoids inventing topics when evidence is missing, fall back safely if Olamas fails. Fall back safely if Olama fails, and writes everything to an atomic manifest. Assistant notes. This metadata generator is now schema ready for the future assistant to invoke safely without exposing arbitrary prompts, URLs, and model controls. Let me see this. Oh, Olama's running. Okay. That's nice to know. Thank you. Localhost too. Okay, so I gotta give him this because we ran into an error and we need to fix it. Metadata validation failure error. It must contain 2 to 3 complete sentences. Let me close this. So it didn't complete the 2 to 3 sentences. That's the error. If it's likely 2 or 3 sentences, if it's not, and which it isn't, then it throws this error right here. What is throw catch error? Exception. Validate structure metadata, source metadata generated .ts. Line 325. Request structure metadata generator. Type 1 failed. Test files failed 1. Test 1 failed. Okay. Start at okay. Duration, transforms, environment, prepare. All right, so Control Alt print screen. The sentence was too short. The real Olama connection worked, but the return description failed the application's 2 to 3 complete sentences validator. So milestone 8 is closed, but not fully approved yet. This is useful. The integration test exposed a real mismatch between Q1's output and our validation logic. Do not remove or weaken the 2 to 3 sentence requirement. Give Copilot agent this prompt. Short explanation, the local user agent answered successfully, but our quality gate rejected its description. We're now making the prompt and validator agree precisely, which is exactly why real integration tests matter. Gotta give them the prompt. All right. Let's see what this does. Llama is running. Is this what we're gonna see all day? I was expecting like a user interface of some sort. All right. So I'm reproducing the failing real integration test first and capturing the exact llama description payload redacted as needed to confirm whether this is model output validated logic or both before making a surgical fix. I reproduce the failure. Next, I am capturing the initial repair safely, and then I'll patch prompt sentence parsing surgically based on actual payload. I'm making a surgical patch now, stronger explicit sentence and instructions and prompt a deterministic sentence parser that handles abbreviations, decimals, initials, and bounded failures diagnostics to capture initial repair descriptions without leaving noisy logging. So it has something to do with abbreviations, decimals, and initials. So I'm making a surgical patch now. Stronger explicit sentence. Instructions and prompts. A deterministic sentence parser that handles abbreviation, decimals, and bounded failures diagnostic to capture initial repair. Descriptions without leaving noisy. I already read that. Apply the surgical fix. Let me press allow. And reintegration now passes. I am running a one. Oh, eh, guess he doesn't want me to read this. Harness, no production login to capture initial repair. I compared old VS, old versus new sentence counting so we can report the exact root cause confidently. All right. So he's running the test again. And I wish I could see that. This is a JSON file. Key value pair. Um, he's definitely putting in the work. So we're not lagging in there. PX library TXX. And he's taking longer than usual. This looks different. He's logging a lot of stuff. My notification is green. I am running one additional non-production diagnostic loop to find and record a concrete real Alamo description that the old validator would reject. So I can, I read that before. Let's give the final response. I'm not sure if I'm still reading all this stuff. All right, let me read it because I haven't been reading it. So let's keep let's keep practicing. Practice makes perfect, right? So he says his final verification is green. I am running one additional non-production diagnostic loop to find and record a concrete real Olama description that the old validator would reject. So I can report the exact problematic description and root cause precisely. Implemented a surgical fix for the failing real Olama metadata integration test without weakening the 2 to 3 complete sentence requirement diagnosis. Reproduce the failure with under real integration test description sentence validation failed in generator 325. Added bounded failed only diagnostic, no normal operational logging. So initial and repair attempt description previews are attached only when validation still fails after retry. Capture real Olama raw for initial and repair attempts in a one-off diagnostic run with redaction applied in reporting. Initial description. This tutorial explains how to build a local user agent video clipper using tools like redacted term. It focuses on deterministic validations and conservative fallback metadata. A repair description. This tutorial explains how to build a local AI video clipper. It focuses on deterministic validation and conservative fallback metadata. What's the difference? Well, he took off that bracket stuff. I wonder why. Root cause, conclusion, primary. Model output occasionally violate sentence shape constraints in real runs. Also address legacy sentence splitting was naive for edge cases like abbreviation, decimals, and initials. I replaced it with a deterministic local splitter so valid content is not falsely rejected. No, the exact raw description from the first historical failing run was not recoverable retroactively because that run occurred before bounded preview capture existed. Above capture descriptions are from the same real provider path and both initial repairs excuse me were inspected as requested. All right, that's enough reading, people. I'm gonna get. First. I'm gonna keep it. Uh-oh. There we go. Then I'm gonna copy the final response, and it looks like we passed, people. It looks like we passed. And I'm gonna go ahead and give this information to ChatGPT Codex. I wonder if this makes me see like I'm looking down. Yeah, it's because I'm stretching my legs. My laptop is like a little lower. So mouse away is now completed and approved. The real Llama pipeline passed end-to-end. Node successfully called local QN 2.5 structure JSON was returned. Invalidated, invalid description triggered exactly one repair attempt. Sentence validation now handles abbreviation and decimal correctly. Deterministic fallback remains available without masking integration failures. Type check, full test, build, and real Olama integration all pass. The repair output ending in question mark period was correctly considered malformed. The stronger prompts and validation detect production metadata from that kind of model mistakes. Let me see. I did notice the open and close brackets, not curly brackets, regular brackets. And that's where I questioned it. But I don't see a question mark here. I just see an apostrophe. Or is it an apostrophe? Yeah. Grammar right out the window. Yeah, that. So exclamation? Gotta look into that again. All right, so all right, let's go back to this. One minor privacy safeguard for later. Keep fairly previous short and ensure they never contain full transcript context. An opt-in diagnostic environment flag would be appropriate if richer previews are ever needed. You can clear the test variables. Let's clear the test variable. Silently continue. So short recap, clips can now receive locally generated titles, meaning that offline, right? SEO descriptions and keywords with strict validations, repair, safe fallback, and an atomic manifest. So the next logic milestone in milestone 9, A, thing command line interface that runs the complete workflow on one real input video from probe through clipping metadata and manifest without adding a UI yet. So I guess this is the last step before we actually add the user interface. This is the last step in the back end process. And then we're gonna go and build the front end. Hopefully that's the case because I don't mind seeing this work in real time, you know? Though I prefer for it to work now before we go into the user interface and creation and then get a whole bunch of bugs and errors, you know? We don't want that. Absolutely not. Um, all right. All right, let's copy this. I'm gonna go ahead and silently continue. Hmm, to go on to milestone 9, please. Let's see, we're gonna have to reconnect and all that good stuff. I think I have to set this up right here. Okay, so now copy this entire prompt into GitHub Copilot agent, mention 9. Agent, Copilot agent, milestone 9 will create the first real command users. 9. Milestone 9 will create the first real command users can run without adding a UI or changing the processing architecture. See, it's moving. It's because he's still writing. What is he writing? I don't know. Yep, this is gonna be maybe longer than Milestone 7. Milestone 7 almost took like 5 pages. And that's great. I like all this skill prompt and stuff because it means that we're getting down to the nitty gritty. It means that we're putting in work. That's what that skill prompt means. It's amazing, if you ask me. So in plain English, this milestone turns everything we have built into one command. It does not add new video intelligence. It safely connects all the existing pieces so we can process a real video from beginning to end. Great. Let's do it. There's nothing to it but to do it. I'm gonna go ahead and copy this. Give this prompt to my very useful Git Copilot. Amazing, amazing senior developer, let me tell you, or LLM, large library model. Gotta look that up. Get that right. It's very important. I'm implementing milestone 9 as the thin command line interface composition layer around existing processor flow with strict argument validation, safe output handling, exit code mapping, and tastable dependency injection. I'll first inspect current entry points, scripts, and error types. Then wire the CLI modules and test without refactoring existing pipeline internal. Yeah, I'm thinking about building a stock market application, buying stocks and selling them. But I have to learn the basics. Okay, so now I've confirmed there is no existing CLI layer and identified the exact error types available for mapping. Yeah, I thought the CLI was my terminal. Or is that the one where I can prompt my terminal and get a response from my terminal, just like I can do in the chat panel? We'll soon find out. So next, I'm implementing the new CLI modules plus one minimum additive processor option for transcript required mode and manifest path placement, then wiring scripts and tests. I've added the CLI parcel progress composition modules. Next, I'm wiring the runner and entry point with strict validation. Exit code mapping, JSON, human output rules, and cancellation handling. Then I'll add tests. Here we go. This is the last one I have. Let me see if I could read the prior one. No, I don't. Yeah, I don't want to look into this type of error right now. I want to look in these. That's if else. If yes, then we continue. No, then we don't continue. I don't think that's or. Or is ampersand. So, yeah. This is why I'm constantly trying to keep up to date with my coding because this is not my 9 to 5, but this is what I enjoy. So the model wants to edit. Okay, let's go. He's still working on adding the JSON human output rules and cancellation handling. So I've completed CLI implementation plus docs test, and now I'm running the test, the type check, to catch compile issues before final validations and refinements. Okay. Well, this is a first. I have 0 viewers. There was usually 1 viewer. Eh, that's fine. My viewers will come. They'll be rolling by the dozens. I completed CI implementation. Okay. He's still running the type check. Okay, let's allow. He's running a push command. Process help. Okay, great. So implementing milestone 9 as a thing as a CLI and composition root of the existing processor orchestration, restrict argument path validation, safe output behaviors, type as a code mapping, JSON mode, boundary level cancellation. Okay. It says here root command npm run process input np4 output job output help npm run process help npm process version support option. Okay. So composition root dependency list. Real FF probe probe VI FF probe video probe real whisper worker pipeline. Okay. Additive contracts change and why. The output directory safety behavior input must exist and be a regular file. Output directory was created. If missing existing output directory must be empty. All right, there's a lot of stuff going on here. Exit code mapping. Let's go ahead and copy the final response and let's keep it while we're at it. Okay. And let's give this response to my main man over here, Mr. Codex. Oh, show the texture. This doesn't tell me how much usage. He says it looks correct. The final requirement is the real end-to-end CLI test. So use the existing 10-minute fallback feature. Generate a unique output path so nothing can be overridden. Test performs the whole workflow. Inspect the 10-minute video, force the non-transcript fallback pipeline, detect silence, audio, scenes, boundaries, plan 2 valid 5-minute clips, render both clips, generate local metadata, write and validate manifest.json, confirm there are no leftover partial files. All right. So it may take several minutes before FFmpeg will encode the full 10-minute source. Keep the terminal open and avoid running another heavy video processing task simultaneously. A successful resource should show the CLI integration test parsing and recreate and create a timestamp. Okay. And after it passes, clear the temporary test settings. So let's copy this. Let's put it in our command line prompt. In this case, PowerShell, no? And go. Oh, something happened. Did I run? Let's see. Yeah, it gives the same error. Show alt screen. There's this is a first. Well, not really. I usually don't get an error in my first try. All right, let's see what he says. I'm shrinking again. I wonder why I keep shrinking. Beetlejuice, Beetlejuice, Beetlejuice. So he says here the project did not fail. The test was skipped because data outputs did not exist. So result path failed and test output directory remain empty. Use the existing data directory as the result base. The CLI will create the new nested output directory. Okay. The three right host lines confirm that all integration test settings exist before Vitess starts. Vitus. All right, let's see. Okay. Press enter. And now we shall get a correct type check test. He did say it was going to take like 10 minutes, and it took less this time. Type check. So let's see what happens now. Control print. So it says they both passed. So let's see. It's very quick too. So what happened previously? Video path successfully resolved. Output base failed because output did not exist or data did not exist. Output variable consequently became null. Consequently, integration tests safely skipped because it required environment. Its required environment wasn't complete. That safety behavior is correct. Run the correct block and let the encoding finish. Let's see. Success. Milestone 9 is complete and approved. The real end-to-end test passed in about 24 seconds. It confirmed that the application can accept the real video through the CLI, inspected with FF Probe, run fallback silence audio scene analysis, plan valid clip boundaries, render the clips with FF MPEG, generate metadata, write and validate the final manifest, leave no unsafe partial output behind. Your complete test output is here. You can open it now. You should find two playable clips on the clips. Oh, that's interesting. Let's see. Let me open this again, just in case. Let's set explore. So. Oh, sweet. Very interesting, my dear. So the first clip. Look at that. And it's 5 minutes long. And it's noisy too. And this one is like, okay, so this is, oh, look at that. Interesting. Anyway, let's look at the manifest. So the manifest says here, okay, we got the schema version 1.1. The source comes from fallback source on 600. The file name is fallback source 600 MP4. The pipeline used is the fallback one. I believe it's pipeline B. Generate at ISO. The clip is clip index 0. The start second and second is 300. I believe 300 is 5 minutes or 3 minutes. Output path, clip 001 MP4. The title short video clip with silence midpoint. A 300-second clip from a video stream ending at a silence midpoint near a scene change. The technical details include H64 video codec. Okay. And a resolution of 320-180 at 10 frames per second. Providers Olamo. The keywords is video clip, silence midpoint, scene change. The signing transition occurs around the 5-minute mark. The video shows a brief pause followed by a new scene. Okay. Not too shabby. I like it. Alright, so let's see what's next. Then clear the temporary variables. Sure, we have now proven the complete local workflow. Not merely isolated components. A user can provide a long video and receive duration, save clips, plus metadata through the command. So let's go ahead and silently continue. Okay, so what's next? What's next? What is next? I think this is the part where we create the user interface, I believe. And if that's the case, I'm wondering if we should continue, because that might be a challenge on its own. Next milestone 10, provide pipeline A end to end with a real spoken video. So far, we have fully proven that no transcript fallback workflow. We now need to confirm that a real 10 to 14 minute spoken video can transcribe locally with faster whisper coda, detect semantic conversational boundaries, produce a valid, cut the video accurately, generate transcript grounded titles and description, write a correct manifest, no implementation changes should be made first. This is an acceptance test of the code we already built. Use a spoken video between 10 to 14. Avoid private materials if you're recording a stream or streaming a test once the video is placed. Okay. Why this comes before the UI? Both core pipeline must be proven with real media before we wrap them but wrap them in buttons and upload screens. Otherwise, UI work could conceal processing defects and make diagnostic harder. After pipeline A passes, the next stages are milestone 11, local API job layer with progress status. 12 is simple upload and process web interface. Later, assisting command routing and optional 916 face on tracking reframing. For milestone 10, the immediate step is choosing a or placing a 10 to 14 minute spoken test video. So let's copy this. So I'm not sure on what I'm supposed to do here. If I'm supposed to upload the video now. It does says use a spoken video between 10 to 14 minutes. Avoid private material if you are recording. Okay, let's start. Let's start. Okay, let's begin with the test video. Don't run the process yet. Place a real spoken video between 10 to 14 minutes inside here. Use a simple file name without personal information, for example. Then verify Windows and FF Pro can see it. Okay. So I have to open this. Okay. Look at that. Right? Let me go ahead and open this here. Hmm. um, Let me open a new window. I like to inspect the windows I have open before I close them, and I haven't inspected that one yet. Oh, look at that. These are all the tests we made. It's pretty cool. Cutter source, fallback source, probe test, and whisper speech. So we have to put in a video in here. That's 10 minutes. Let me look at my videos. Most of my videos are like way longer than that. You see, they're hours, half an hour. So I have to find one. Let me look for it in my other video source file folder. And I'm looking for 10 minutes. This is 2 minutes. This is 19 minutes. Let's take this one. Or this one. I like this one. We're gonna copy it, put it in here. He says not to use such a long title. So maybe I gotta look for another one that's shorter, right? Switch setup. Nah, this one is long. This is 8 minutes, 17 minutes, 57. Loading is visible. Let's try this one. It's 17 minutes. Put it in here. There you go. Let me put this into detail view. Details. And now Control Alt print screen. Let me see what he says now. Okay, so he wants me to name it this before anything. So let's go ahead and do that. Or I could change it in the code itself over here. I'm not. There you go. Okay, so now we got to test it and see if it does exist. Over here, Pro V, enter. Finish true. Okay. So expected. Test path returns true. FF Pro prints the duration in seconds and 10 to 14-minute video should show 600 or 840. If your file name is different, replace it All right, send me the terminal results and I'll verify that everything went fine. Okay, so Control Alt screen, and it's successful. So let's just make sure that he verifies it. It's a lot longer, so that's why the final output was 1030. It's 1030 seconds, 0.55. Okay, the video is valid and suitable. Fog says duration is 10,000 seconds. Equivalent approx 17 minutes 11 seconds. Expected results. Nice. Eclipse. I'm already liking this. I am already liking this, my friend. Okay. Each between 5 to 7, although it is longer than the original suggested 10 to 14 minutes, its duration is mathematically feasible. 3 times 300 seconds equals 900 seconds. 3 times 420 seconds equals 1260 seconds. So your 1030 seconds video fits safely inside of that range. Now run the real transcript pipeline. What video is this again? Loading is visible. Which one we ran? Oh, yeah, this one. Test path, yes. We're testing the path. And then we're testing for errors. Show entries, format duration. Default non-print wrapper. Then verify that Windows and Mac Pros can see it. Alright, so let's run this now. What will happen? Whistle transcribes the full 17-minute video using your RTX. Okay, great. So see this. This is gonna be very, very. This is gonna be fun, right? That's what it's gonna be. So let's go. Let's go. Ooh, errors. Let me see. Says here error input file not found. Input file was not found. Code 3 API location failed. Let's go ahead and print the screen. I'm gonna go ahead and close the Explorer so we can have a little more space here. Transcript. Control Alt print screen. They're supposed to give me a transcript, full 17-minute video using a this transcript analyzes finds conversational stopping points. The planner chooses 3 durational save clips. FMmpeg renders them. Olama generates transcript grounded metadata that the app writes manifest.json. This will take longer than the fallback test because it includes real transcriptions and full video encoding, keeping the terminal open until the command returns to the PowerShell account. This is going to be interesting. He's thinking. The transcript did not start. Just transcription did not start. The CLI correctly reported that it could not find the input, but this exposes a real CLI path resolution bug. What happened? You launched npm from the repository root. npm executed the workspace script inside the apps API. The CLI resolved write transcript source.mp4 relative to apps API. It correctly searched here. Okay, so where was it searching? Where's it supposed to search on first? Oh, that's why. Searched correctly, we're supposed to search. The root CLI documentation promises a repository root relative path, so we should fix this instead of working around it with absolute path. Give code path the agent this prompt. So it looked in the they weren't connected. We went from work to apps. Relative to apps AP. So we need to give him this so we can get the absolute path. Sure, nothing is wrong with the video. Whisper or CUDA or CUDA or CUDA. The CLI stopped safely before processing because npm's workspace changed its internal working directory. We're correcting that contract before retrying the real video. Oh shit. Excuse my language. Okay, yo. Oh. Control C. Shoot. Let me close this. I don't like the way this looks. I don't like this happening. I'm just gonna kill this terminal. Alright. This goes in here actually. So it's gonna hash the CLI path, the solution in one place, so all relative alpha path use invocation directory semantic. Then add focus regression test and rerun type test. I found the exact spot. Path normalization currently always uses process.cwd. I am patching a single invocation based result. And then adding regression tests that asserts resolve input output path passes passed into the processor. So the path-based fix and regression suites are in place. He's now running the required validation commands. He should pass. He should pass within the first test. With type check. So no dependencies. The path-based fix and regression suites are in place. I am now running. Okay, root cause CLI resolve relative path using process.cwd from the workspace script context, which is inside apps API during npm workspace execution. All right, let me keep this. Let me right click here, copy final response. I'm getting tired, guys. I'm not reading all that stuff right now. Enter. Oh. Okay. We should be able to run the previous command. Okay, the path resolution is fixed. It's correct and fully validated. We can now retry pipeline A using repository relative paths, which also verifies the fix under real conditions. Run this new job. This time CLI should resolve the input to data work transcript. Copy this. And it's a command, so it belongs in here. All right. Input accepted. Selected pipeline mode transcript. And what's going on? So, is he doing anything? Shall I move up and down? So now, this time CLI should resolve the input. Pipeline reported as transcript. Okay. 3 clip generated. Every clip lasts between 300 to 400. Titles and descriptions should reference the actual spoken content. Output should appear under the new. Okay. Data outputs directory. Manifest should report llama or honest deterministic followed by providence for each clip. Keep the terminal open. Transcription plus rendering may take several minutes. Oh, so it's probably still working. I could peer into it. I probably should. It's supposed to be in outputs. Data and then outputs. It's supposed to be in here. Flips. No, only got one. Partial. It's not the one I'm looking for. I think it's still working. Control shift alt screen. I think it's still working. Processing. It's only one C. Wow, it takes. Yes, it's still processing. The signs are the PowerShell prompt has not returned. The cursor is on a blank line below. Select the blank line mode transcript. No errors are appear. The input path is not correctly resolved. It most likely transcribed the 17-minute video. Whisper does not currently make continuous progress messages through this CLI, so the terminal can appear idle during the stage. Do not close the terminal or press Ctrl C. If you want to verify the activities, open a second terminal and run this. You can also check GPU activities. Once a running Python process GPU memory compute usage confirms Whisper is working after the transcription. The application will plan boundaries, echo 3 clips, generate metadata, finally return to the C drive prompt. Okay, let's see. Let's open a new terminal. New terminal. Control V. Huh? What the? I didn't even working set. What happened? Ay, 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 what me right here. Control. Control. And then this is something. And it tells me I can run this one. So it looks like it finished. Nope, it's not finished yet. Let's see what he tells me about this. I need a break, guys. I'll be back. Put over here. Oh, he's still working. Wow. A lot longer. Just imagine what 2 hours would take. Well, So it's done. Okay, let's see. I'm back. So it says here, input accepted, select the pipeline mode, transcript, media inspected, duration, selected pipeline, transcript, boundary plan produced, 3 clips, clip render 3, metadata generated 3, manifest written. Okay, done. Output. Program smart video clipper. Okay. It's decoding, transcribing the video right now. FMPAX applies the media stream while Python performs transcriptions. Everything looks normal. Leave the original job terminal open and wait for either additional stage messages and successful completion summary or a clear error followed by the PowerShell prompt. Do not run the processing command while this one is active. Okay, so let me give him this, and I'm sure I got the output over here. Clips. There they are. Clip 1, clip 2, clip 3. Let's see. Welcome, everyone. Welcome. Today we have a very interesting video, actually a very important video to make, because this is going to be a part 2 of a very, very, I don't want to say a long list, but it's definitely going to be a playlist. So this playlist is going to be based on our website that we're going to build. It's going to be similar to a portfolio website, and also similar to my actual website. If you look, so let's go ahead and keep it. And I believe that's more than enough information. And then we're gonna go ahead and read this command, and then it's gonna give us instructions to follow for us to eventually learn what these elements do. You know, so it's ample information, which I think is very important. Okay, so here we go. So that looks great. Let's see how it finishes. Wow. So we go to my CSS over here, and then just write a rule to hide that visible subdomain. We'll get into that as we move on. Okay. That was amazing. It cut off right on time. Oh my god, this is so good. So now this is so good. That's how it works, right? So yeah, becomes the single class, and or remove the whole loading user interface. That was so in this good. HTML, this is what we're talking about. This I can't believe it. I cannot believe it. This part of the expanded. Don't believe it. Trigger dot means when it's doing that, it's just telling us this is where the element lives. Okay, this piece of block of code. Oh my lord! If we're speaking about this element, just look for it. There you go. That's the one. Can you guys believe this? So we could use it like this. That little snippet was incredible. So let's go ahead. Let's see right here. If it does exist, then run the rest of the code block. So I'm gonna take this in and take off the space, white space, enter, and it's still undefined. So now what I'm going to do is that's good. That's good. Let's see with the last one. So I'm gonna go ahead and copy this code right here. And then I'm going to paste it here, and then I'm going to console log. Wow. Okay? So that's what I'm gonna do. Enter, and now I actually get an output display, right? That was amazing. I decided to output the the loader. Incredible. All right, so it's a simple mechanism right there that we learned. So now let's go back to our transcript. So right now we can actually add more to our CSS. In this case, we're gonna hide our loader, right? Our outer wrapper loader. Okay, so all we need to do, let's go ahead and read over here more or less what you did, because I did prompt them to add more, to add this piece just for practical learning purposes. So let's go ahead and read real quick what he says here. So I'll update the transcript to capture exactly what we just modifier is right here. The inner is the modifier. So we're gonna learn how that works as we move along, but definitely, I hope you guys grasp this part. It's very important. Not sure what happened with my camera. Acting kind of funny. So I'm gonna go ahead and copy this. This is the block, and these are the elements, and then the modifier is. Oh, that's not based on. Let's see what's going on. Oh, okay. Yeah, that belongs there. That's for sure. Let me go to my actual HTML, which is this one here, and just right click it and run. Open with live server. This is what we get. So now, in order to hide it, all I have to do is just add the class over here, and it's hidden, and save it, and then now it's hidden. That's learning mode. That's the whole point of that section right there, is to learn about the outer wrapper class, the loading outer wrapper class, and that it's a compatibility book. You get to compare it based on displaying it or not displaying it. You know, it's a compatibility book. It's also part of the BEM, I believe, block element modifier. So this is the block, and these are the elements, and the modifier is right here. The inner is the modifier. So we're gonna learn how that works as we move along, but definitely, I hope you guys grasp this part. It's very important. Not sure what happened with my camera. Acting kind of funny. That's great, though. That was amazing. Now let's look at the transcripts now. Let's go back over here, the manifest, right? So we have building a website with loading UI. The video explains the process of integrating a loading interface into a website design. It covers how to use CSS to hide specific elements during development. My God, that's really nice. That's really nice. No. So, success. The first real transcript job completed completely. It confirms input duration, right? Pipeline actually uses transcript. Whisper small, so 16, and CUDA. Boundary is 3 clips. Clips render is 3. Metadata generator is 3. So let me see. Manifest ran successfully. The metadata part, I didn't see. So important, at the bottom of the terminal, you appear to be entering the processing command a second time. Press Ctrl C now while you see the prompt so you do not accidentally run another 17 minutes. Then open successful output. Check three. Check three things. All three clips play normally. Listen near the end and beginning of adjacent clips, whether the cuts feel conventionally neutral. Open manifest that JSON and confirm each title and description accurately represents the clip's spoken content. Short recap: Pipeline A has now worked on a real 17-minute spoken video. It transcribes with your GPU, selected semantic boundaries, produce three durational saved clips, and generate transcript around the metadata. The technical end-to-end test pass. The remaining check is human quality review of the cuts and metadata. But I thought he was gonna create three different transcripts for the three different videos. So that's something I want to understand. Oh, he did. He did. I didn't scroll down. That's the problem. So, um, 0, okay, and then this is number 2. Okay. So it starts at 0. Okay. This one starts at 385.24. Okay, and it ends at 6. And this one is HTML element inspection and testing. This clip explains the process of inspecting HTML elements for testing purposes. It covers adding CSS based on inspected elements and running tests using developer tools. Wow. Okay, and the third one, code snippets and CSS modifications. The speaker demonstrates copying and pasting code, explaining the console log output. They also discuss hiding a loader by modifying CSS classes and adding JavaScript snippets. Holy whack-a-mole. So I'm gonna put here, I concluded successful. I conclude success. Success. That's amazing. I mean, it might need a little work, but I have to watch the videos completely to make sure that the title and the descriptions are fully correct. Though I concluded it to be successful though. Very successful. Also, intent is complete and approved. Both core workflows are now proven with real media. Pipeline A, whisper transcription, semantic boundaries. Pipeline B, silence audio, scene analysis, valid boundaries. Okay, CLI, complete local processing from input videos to clip. You now have a functional local video processing engine, not merely scaffolding or mocked components. Next is milestones 11. Build a local API and job status layer so a future web interface can upload a video, start processing, monitor progress, and retrieve results without invoking terminal commands. I don't know if I should start this now, people. I think I should get some rest to get ready for tomorrow. This is going to be one of the most exciting parts, I think, the user interface. I have to check these videos promptly before I make a final decision. So I'm gonna take a break. Thank you for joining me and see you guys soon. As soon as I make some verifications and look over the videos and make sure that everything is running correctly as expected. All right.